In this video, I'm going to introduce cryptology and cryptography, which we've just started in grade 7. Cryptography is the science of coding, essentially. It's encoding messages. And the first type of code we're going to study is called Caesar ciphers. And these are named after Julius Caesar, who was a Roman general, a Roman emperor. And Julius Caesar, he had this problem. He wanted to send messages to his generals in the field. But when he sent messages to his generals, of course, he had to give the messages to someone on a horse and they would ride to the general, deliver the message, right? But if the person who's the messenger, the deliverer, if he got stopped and captured by the enemies could read the message, right? So he didn't want that. And he wanted to find a way how he can send a message to the general can read it, but if the messenger gets captured, the enemies cannot read it. So he thought, okay, I need to encode these messages. And if I encode it in a certain way, I can tell the general before he leaves what the way to decode it is. So that any message that he gets from me, he can decode it, but the enemies don't know the code. They don't know the key to decode it, so they cannot read any of the messages. Okay, and we'll talk about keys in a minute, like how to decode. This is an encoded message. It's a word that your teachers say to you every day. It's a word with 6 letters, but it's been encoded. And what I did to encode this is I used a Caesar cipher. And a Caesar cipher just means a shift. So for every letter, it's either shifted 1 letter this way, or 2 letters, or 3 letters, or 4, or this way. So for example, if you had C, and your shift was like plus 2 letters, you would write E. If your shift was minus 2 letters, you would write A. And the general would know how much your shift is. Okay, so try and solve this. I use the shift, and it's a word with 6 letters. This shift is plus 1. It's a plus 1 shift. And this word is listen. M is 1 bigger than L, 1 letter bigger, 1 letter bigger. J is 1 bigger than I, etc., etc. This word is listen. And the key is plus 1, right? So if I was Julius Caesar, I would have said to my general before he left, listen, every message I send you, he will be plus 1. And so he'll know how to decode every single message that I sent, right? Okay, that's one type of encoding style. Another type is a substitution cipher. A substitution cipher directly substitutes the letters in the word for something else. And we'll use numbers. So with the substitution cipher, I can rewrite this word listen as this. Where L is the 12th letter in the alphabet, I is the 9th letter in the alphabet, and so on and so on. I can also put both of these codes together. So I can change listen into, so I can do a substitution cipher on listen, and then the Caesar shift. This time the Caesar shift is on the numbers. So I can do plus 3. And okay, then my coded message looks like this, where every number is plus 3. But after it's decoded, this word is listen. Now, someone who intercepts the messenger is not going to understand these 6 numbers. But our general can understand these 6 numbers because he can decode with like -3 and then convert to letters. Okay, now we're on to modular arithmetic, which is a key part of being able to decode ciphers. Modular arithmetic just means after you get to a certain number, you start again. And we can look at an example. What if our letter was Y and we had a shift of 3? So what if our letter was Y and we had a shift of 3? Well, we would write B. 1 jump, 2 jumps, 3 jumps. We would write B. If our original letter was X and our shift was 7, we would write E. Right? This is modular arithmetic. It means after you get to the end, you start again. For example, 26 plus 1 in this modular system is 8. Z plus 1 is 8. So if I convert that to numbers, 26 plus 1 is 1. There is no 27. It's a circle, right? It's a circle. And actually, there is a modular system of numbers in your everyday life. Can you think what it is? It's a clock. It's time. If you think about it, if you work in 12-hour time, that's a modulus 12 number system. After 12 is not 13, it's 1. Right? Or if you work in a 24-hour clock, then you have a 24 modulus number system, where 24 plus 1 is 1. It's not 25, it's 1. Because it starts again. It's a circle. Okay then, I have a task for you. I want you to try and encode the word hello using these steps. First, change to a number. Then use the key. The key in this case is not +1, it's 2x plus 10. So times the number by 2 and add 10. Then use modular 26. So if you have a number that's higher than 26, take away 26. For example, 30 would be 4. 27 would be 1. Right? And then change back to letters and tell me what letters, and let's see if you get the right answer. Okay, so let's see if we can work through this one together. It's a combined substitution Caesar cipher, I guess. So if we change this to numbers, we get 8, because H is the 8th letter of the alphabet. 5, 12, 12, 15. Okay, then we're going to use our key, which is 2x plus 10. 2 8s plus 10 is 26. 2 5s plus 10 is 30. 2 5s plus 10 is 20. 2 12s plus 10 is 34. And another 34. And 2 15s plus 10 is 40. Okay, now let's apply modular arithmetic. Mod 26. 26 is still 26. 20 is still 20. 34 modulus 26 is 8 and 8. And 40 modulus 26 is 14. Okay, so then we convert it back to letters and we would write Z, T, H, H, and N. Okay, this is our introduction to cryptography with Caesar ciphers and substitution ciphers.